Thank you very much, everybody, for joining me today. It's my first time at Jfokus. Amazing crowd, amazing conference, and amazing city. It's my first time in Sweden as well, so it's great to be here today with you in such a large number. Hope you'll enjoy the session. And regardless if you're starting or you're advanced with Kubernetes, please address your questions towards me. I'm looking forward to your feedback, but both also to your questions regarding working with Kubernetes and OpenShift, for example. So just ask me at the end. It would be great to hear from you and listen to your stories and experiments with Kubernetes as well. So a little bit about myself. I'm a Java champion and certified architect, and currently working as a developer advocate for Red Hat. But also, I'm a control enthusiast. What this means is actually that I really like for things to work all the time, probably like many of you. And I'm like always thinking like, what can go wrong? And how I can make things work at their best, regardless of scenario. So sometimes I'm making a lot of worst-case scenarios that can go wrong, and how I could attack those in case they happen to me. You can find me on Twitter at Ambra1508. I know it's kind of an interesting handler, where I'm posting information about the workshops, tutorials, and things that I am contributing to, and of course, events that I am talking to, because I'm talking on different topics, not just related to Kubernetes, but also on Quarkus or on Java as well. So those being said, when it comes to working with Kubernetes, and probably you've heard about this for a long time, there's a good side, and of course there's not so I don't know, great side of it, and that depends of your experience with it as well, and how well you have learned it. So to move forward with Kubernetes, we need to know very well what makes it great, but also what makes it we need an improvement, and we need an add-on, like working with other plugins like Istio, Knative, and others. So, starting from this quote of Buddha, we're going today on the path of automation with Helm or with operators. So probably you've heard since 2015, we're moving into creating distributed applications, microservices. And typically when you're thinking to microservices, a lot of people, possibly yourselves included, are associating creating distributed platforms with a Kubernetes service. So having Kubernetes as an orchestrator, because even though that we are creating independent deployed applications, we're containerizing them, we need a way to make them work together seamlessly for our end users, so that we don't end up with a fragmented experience for our end users. And of course, we do give them those benefits that microservices have promised to us for so much time, such as isolation of failures, deployment independency, and zero downtime. So we don't want our end users to see that our applications were not available, or feel that our applications were not available. And nowadays, downtime I think is not that much a concern, but I think latency and the speed that we're serving the data that the users want are a concern. And of course, today's topic, when working with Kubernetes, both Helm and operators are there to make our life easier when dealing with it. So when embracing Kubernetes, of course, we love Kubernetes because it has some awesome features. And these features are extracted, by the way, from Kubernetes documentation. It's not something that I've come up with myself. And also in the beginning, people were very attracted by this mirage of Kubernetes, because it, first and foremost, it has self-healing. And it has, of course, you can do batch execution, it can scale. It has automated rollouts and rollbacks, all these good stuff. And when you're seeing all these advantages of using Kubernetes, you think that all your problems are solved, so you don't have to be preoccupied by anything else in the future. However, when you're starting to learn Kubernetes, when you're dealing with Kubernetes, you realize that actually these features apply not to all of the resources that are in Kubernetes, that actually Kubernetes is an extensible platform that you should add a few more things and start to work with certain patterns when dealing with it, not just think that these are going to be there available for you regardless of what you're doing. So, those being said, the story of a microservice typically starts from application code. You're making some code, of course. Then you add a Docker file, which is a container blueprint. And then in order to deploy this, to work with this Docker file and to make a Docker image, and of course you add some Kubernetes objects, typically in YAML format. And you can add one or more. depending on how complex is your microservice. And the reason why you're making one or more YAML files is because, well, it's not just your application deployed, but also your application has some configurations that you're typically externalizing, so you're not keeping that everything all together. So at the moment, it seems like quite easy and simple, but then you're starting to think, like, after you're doing the first deployment, or somebody from the operational team is doing the first deployment, they start to ask themselves, like, how are we going to do this if we're like deploying this in 2 environments? Well, we need to write more YAML, right? Because probably there are going to be other configurations for us to be done because it's a different environment, right? And then how about if we're like growing in amount of environments because we just need to test and do some smoke testing or maybe do some integration testing that is available only under certain conditions. So if we're like expanding this to a broader future, then we end up writing a lot of YAML files, or if you prefer, you can write only one YAML file, but, well, even if you're like writing longer YAML files, scrolling is not a very nice option. I don't know how many of you love to scroll in files that have code, but it's very difficult to read, and sometimes you forget where you started and what's going on there. So we should understand our nemesis, and I've seen this pretty much over the internet that developers don't like YAML. Well, YAML, well, it does help us. Kubernetes is working it. We're working with it when it comes to interacting with Kubernetes. And to understand our nemesis and to work better with our nemesis YAML, Helm was the first one that could have helped us in dealing with its complexity of it. So there are some automation heroes when it comes to working with YAML, when it comes to working with Kubernetes, right? And this first automation hero was Helm, because it brought us templates. And these templates were great for us because we could like divide our Kubernetes resources per template file and know exactly the responsibility of that template file and reapply it when needed. So Helm is great for us because it can manage and update multiple Kubernetes configurations from one point. Then it's great because you can deploy many configs that are related to an application, like maybe an application has many config maps, or it uses secrets, or it uses any other resources, or maybe it has also service accounts that are different for environments and so on. So you can deploy these many configs as a single application. Helm is going to give you a single view of what you're doing there, regardless of how you are configuring things. And of course, you can parameterize for multiple environment support. Because for a long time, people were, when they were building YAML files, the reason why we were building multiple YAML files is because there were differences between those environments. So we had like, didn't have that possibility to give a parameter somewhere and like just switch only that parameter when we wanted to deploy. So that's one good thing about Helm. And we're going to talk about its differentiators. But let's see some action first, because I don't want for you to like go into the session without some action. And as said in the beginning, I like to control things, but I also like more complex scenarios. So we're going to deploy today 3 microservices with a nice UI, the last one. So those being said, in my GitHub account, which is going to be shared with you, there are 3 microservices: event, landmark, and ticket store. So event and landmark, of course, they are providing some information about tickets that you can buy for visiting an event, for going to an event, or for visiting a landmark. And ticket store is just its front end. So we are going to use Helm and operators for these today and evolve our application together. And first and foremost, the first microservice that I want to deploy using Helm, of course, is going to be event. And that's pretty straightforward to do by, creating a Helm chart for events. Let me just go to event and, well, chart. And just simply say Helm create. And in this case, I can say event. And one nice feature of Helm is that if you're finding yourself in the position that you are repeating templates, so even more automation, you can use starters even when you are creating your charts. So you can add your own layer of starter above the layer of like creating Helm charts just with Helm create event. So In this case, I'm going to use a starter call event that I have to create my own charts. You can see here that my charts are being instantiated. And the reason why I use this starter is because it also has a validation included to it. So this is a great thing to have for values. When you need to make sure that your colleagues are not inputting some random values for what you're deploying, you can enforce that with JSON schemas when you're using Helm. Let's look at what was created and say tree event. So we got a few things here. We got the deployment where we're going to use it for deploying our application. We got our service. We got a service account because we want to deploy this securely. Test connection is just used for smoke testing, so making sure that things are really working. And of course, values.yaml containing the values, the parameters that we're going to be using when we're deploying. And of course, because we want to make sure that we're deploying allowed values, like the permitted ports, for example, or permitted host names that we're allowing for those to be done, we can use the values.schema.json. This is a very interesting feature that was added, I think with Helm 3, that you can validate what you're putting in a values.yaml so that you don't end up with wrong deployments or unexpected values for your deployments. So the values, it's pretty straightforward YAML. Typically, you have this auto-generated YAML, and you can add a few more things to it and enhance it based on your needs. So in this case, the enhanced part, what I added to this one, is because my events are actually persisting their data in a database. I added the Postgres SQL database there. And those being said, if I'm more interested in details about my chart, how it's going to be versioned and how it's going to be named, there's also chart.yaml that gives me all these details about, having a chart like this, and what's the version of it, what's the version of the application that I'm deploying, and of course a nice description for it. But before deploying this, it would be great to have actually a database there available. So when you're starting the development, it's good to use Helm, for example, when you want to really bootstrap really fast something. And this is how I'm usually trying out things so that I'm making sure that something is working just on my local. I'm just using Helm charts that are publicly available that providers are giving so that I'm seeing that my microservice is working as expected and not just, behaving differently in the deployed environment. So first of all, let's install the event chart. And this one, if you're wondering where I'm getting it from the repo of Bitnami. So let me just clear this, Helm repo list. So if I'm doing this, I can see the repos where I'm having access to. So the repos that I added myself where I can get safely some information about some charts, right? And now if I want to install my chart, I can overwrite the details that are coming from the published charts with the -- set and just have them done here. So this is going to install my Postgres SQL database called event. So just making sure that I'm respecting the values here. It's going to be an event Postgres SQL database. And of course, it's going to also give me information about how to connect the data. So how to connect to my database, what's the password, and so on. As you can see, I'm not using any password here, password value, because it's not okay to know the passwords. I will reference this from a secret. So this is how I can make sure that I'm not posting very important information in a plain file that everybody can see. So in this case, it's better like this, just to reference the secret name and get the information from there. Going back here, let's say clear, we can say now Helm install, what's it going to say, simple. So make a simple installation of event and have this connected to the database as well. Hopefully the internet is going to work well. It's going to take a little while to see this. Let me get here. So the database is already deployed, the event Postgres SQL, and yes, now we're waiting for the simple event to be deployed as well. Now it's going to be created, instantiated, and up and running. Okay, running. Okay, it's blue now. Good. So now that we have the first microservice deployed, just let me go and say API event to make sure that I'm getting some data. So I'm getting some information from it. This is one way of working with Helm. The other way of working with Helm, when we have dependencies, like in this case, you want to really fast test really fast how you are deploying both the database and the microservice, we can use the leader chart approach, meaning deploy them all together. So we're going to do this for the landmark. Let me go up, cd landmark. And here, I'm going to say Helm create leader using another starter of mine, which is leader. So what is happening in this case with the leader approach is that I'm not using templates anymore for this because I'm just wanting to deploy two charts together as subcharts. This approach allows me the possibility to define global values in my values.yaml, for example. So I can overwrite these values that would be typically inside my microservice and give them a global value here. And if, for example, I need to reference my, sorry about this, I need to reference my, my dependency, I can do that with my, let me just get it like this, with my dependencies in the char.yaml. So whenever I need to like deploy all together a microservice that has an external dependency and needs to have that available, I can do this with a leader chart approach. Just give some global variables and override them in the values.yaml, the global one, and just specify the dependency, which is the version of the database in this case, and the repository, and so on. So only this would be needed. And now we just need also another subservice and go to leader and charts. And we need to deploy the actual landmark service because, well, we also need to create that one. So create landmark minus starter landmark. So creating landmark. And if we're going to look into this one right now, because I'm defining globally my database values, if I'm looking here, I'm not needing any more these values regarding my database defined there because they're going to be propagated from the upper side to down to the down microservice itself. So that's one advantage of doing this all together. Let's go up and deploy the leader. So let's say Helm install leader from leader. And this is going to just do the deployment altogether. It takes a little while for it to be up and running because the database, it takes a little longer to be instantiated and afterwards the landmark. But you're going to see them all together. One sec. Let me go in this smaller. Okay. So these are the two, and this is the leader deployment. Okay. Now, just wait a little bit for it to scale for the database, and then you're going to see the landmark also coming up and spinning up once the database is available. So let me get here. Application is ready. And again, API/landmark. Great is working and seems to be fine for the moment. So there are some differentiators that come with Helm, for example. So it's easy to prototype things. Even if you're using Helm without starters, it's easy to have a prototype for your deployment. You get a basic deployment service account, or even ingress, and you can like work with that and build upon that. So you're not writing your YAML file from scratch. Then you can separate the non-final values that are, you know, the template related from the actual object. So it's great that you don't have to, like, all the time like hard code the values of your parameters inside your Kubernetes resources. Then you can deploy many configurations just through a single chart instance. You're going to maintain only one chart instance, but multiple values files. Just say values.def.yaml, values.qa.yaml, and you can deploy with that specific set of values, not necessarily, you know, creating new charts and new YAMLs and new stuff. It's less YAML to maintain thanks to those templates. And then you can check the nested values at every level. So Helm has a great range of functions that you can work with, that you can validate that if something was defined, then yes, execute this part, instantiate this part of the Kubernetes resource. But if that part was not defined, please ignore it. It can also parse YAML. It can also do some more validations over it. So it's quite extensive and great when it comes to making sure that you're deploying the right thing. Now, there are some distinctive Helm aspects that make it even greater than just working with regular Kubernetes resources. And one major improvement was the fact that you can automatically roll deployments via annotations, because you know that, for example, automatically rolling deployments when something changed regarding your config map or your secret is not out of the box available in Kubernetes. So if you're changing your config map or your secret, your deployment is not going to go immediately and redeploy or restart your container with the new values. It's going just to function as before, because your application already started with a set of values. So Helm, in this aspect, can help you with that. Now, it also encourages reusability. So you can use include, like the directive for include. You can use _helpers.tpl to make more templates. And you can also use the template function to make your own template within the template. So it's quite strong and powerful about that. More about this, if you are uninstalling something, you can say Helm uninstall. Like I did Helm install, you can say Helm uninstall. But if you want to keep a resource, you can say that to Helm and say, hey, use the annotation resource policy to keep a resource upon install, so it can be there for you, and it can be kept even if you're uninstalling that specific Helm chart. Now, if we're looking now at the demo of the status of our demo, we have 2 microservices, each of them having their own databases deployed with Helm is great, right? And they can scale because they're stateless apps. But if we're looking to this, these 2 databases from Kubernetes point of view deployed with Helm, there's kind of a complexity around them and maintaining them, meaning what the database. You also need to upgrade the database. You also need to make backups with the database. And just working with Helm for databases in Kubernetes is a starter, but on the long run, you need more automation. So at the maturity of a system, if we're looking back to what we're building, and we're like extending this for multiple environments and keeping those databases up to date and doing the backups and doing all the upgrades over the databases in multiple environments, it's going to come with some time spent by us to do that. There are ways to work with that, but maybe there's a better way. So if we're looking on long term, if you want to deal with growing complexity, operators can help us. So if we want to improve our future and spend less time on, maintaining stateful sets or let's say Kubernetes applications that are stateful by design, operators are there to help us. And probably you've seen this, that many of your resources for, let's say, monitoring or for logging, they are coming in the form of operators, or they're advising you that it's better if you're installing this via operators instead of like having your own customized YAML files. So there are some benefits of using operators. Well, it's because not only that you can automate more, clients like kubectl or the dashboard, they're automatically working with them. So what this means is that you don't need any other CLI like I used earlier Helm to interact with Helm and install my charts. But I don't need any other CLI when creating and working with operators. kubectl works fine. Then resources created via operators are integrating themselves with the Kubernetes role-based access control system, which is great. Also, operators, in the beginning, their main usage was like, hey, they should serve us for backing up data, for configuring our cluster, so for automating even more. And because they're working seamlessly with Kubernetes, and they are subscribed to the events coming from the Kubernetes API, operators can heal the resources that they manage. So that's a very important aspect, and I'm going to show how that works in a moment. So what's next for our app? We can discover and decide which operator to use on operatorhub.io. So that's a site that you can go and see what operators are available. community, and not only community. You can deploy operators, the operator of your choice, with the deployment instructions that are coming there, and you can keep the Helm charts for installing the applications. So Helm is great when it comes to working with stateless apps, but if you're like working with stateful apps or something that's stateful, then operators are there and to help you even more. And of course, you can maintain the PostgreSQL database via the operator. So that's the main goal for our talk. And before creating an operator, let's make a switch here. So let's clear. And in this case, I want not to use for event anymore, the event PostgreSQL database. I want to use a database that I have instantiated from an operator. So the asset Postgres is coming from an operator. So I want to switch this for my event. And I can swiftly do that with Helm here, just going and replacing this part. And I need also to switch the secret that I'm using because it's not the same, it's belonging to a different resource. Let me go here. Let me see if I find the secret. This one, nah, I can go here. And secrets, and say operator. Yeah. So my secret that contains the details for event, in case of the operator one, it's operator minus event minus PostgreSQL. So just need to put this in front of it. And just uninstall the event. So for you to see that it's crashing. So I'm installing the previous installed database, getting out of this one. So this one is going away. And of course, now I need to upgrade my event. So let's go to event and say Helm upgrade, the simple deployment I did earlier from the chart event. So this one, what it's going to do is going to just change the version and of my release. So it's going to be release number 2 with my Helm charts, but nowadays connecting to a database that's coming and being maintained from an operator. So you can see now that revision is number 2. So Helm list. And you can see also with Helm list the revision of the apps. So you can see the leader is like revision 1 and simple to revision 2. So this is how you can seamlessly upgrade without just changing everything and just going forward with it. Let me go and just open the simple event and making sure it's up and running. So event. So yeah, things are still working even after switching to the operator. You can create your own operator if you want to. So there are multiple ways to create an operator. You can use tools like Kudo, Kube Builder, Method Controller, Operator Framework, or if you're a Java developer, Java Operator SDK. And there are multiple resources available on how you can create your Java operator. And Quarkus, by example, it has many resources available on how you can create a Java operator, an operator in Java with Quarkus, for example, and maintain that from the comfort of a Java code, which is great. So how about creating an operator for us, like from scratch? Because I want to get to this demo final view, I'm going to make an operator for my ticket store service, the last one that I want to deploy. So this one is, again, scalable application. And because I started with Helm, we're going to evolve this service to being deployed with an operator from Helm charts. So we're going to evolve it from starting with Helm charts for it to the operators. The way to do that, the easiest way to do that, but of course, if you're working with private repositories, that can be done as well. This is just the easiest way to try things with operators in Helm. So what you can do, you can use a GitHub repo as a Helm repository. What I did, I actually check out the GitHub pages and put my ticket store Helm chart, packaged it and put it there in my GitHub pages. So I can publish my charts on GitHub and use them as a Helm repository similar to the Bitnami one and so on to get my charts and work with them further. So first thing, packaging the charts, then I'm generating an index file based on docs directory. And of course, then I can work with my operator just by, adding the GitHub repo, referencing it. And then I'm just initializing my operator using the operator SDK. And here I can also reference the Helm chart version. The reason being is because if I'm going here in my repo, just go wait a moment. Let me go to GitHub Pages and this one. If I'm going to docs, you're going to see that I have 3 versions of my ticket store because my ticket store evolved in time. So when I'm working with an operator, I can also version what I'm working with. So if I want to like upgrade my Helm chart, my ticket store app from version 1 to version 2 or version 3, I can do this very smoothly just by referencing that in the index and using that in my commands and evolving it further. So I can choose this from all the entries I have here in my ticket store and not just use only one. So there's some flexibility in evolving the API and not changing that much with the evolution of an app. Going back here, then after you're creating your own operator, you can install it and just look at the installation and use the make install run. And of course, you can apply some samples because when you're creating an operator with Operator SDK, you also get some samples based on that. So it's pretty straightforward and easy to just see if it works and is happening for you. So let's go here and work with the ticket store as well. Let me clear this and CD. And of course, let me go to here. First of all, going to ticket store operator and say make install run, just to install my operator and see if it works with my installation. Hopefully there's going to be no error with it. Okay, seems to have started. Okay, so now let's apply a configuration for our operator. If we're looking over this, could not find the requested resource. Let me try it again. If we're looking now in the operator, and in the config and what was generated, remember that I was telling you that the operator is integrating with the role-based access control in Kubernetes and everything. Well, that's because in the generated part of it, you can see that there's the role binding and role and everything generated for you, and you can enhance from there. You can also have the CRD, like the custom resource definition of what you're deploying, and the samples, what they're doing, that they're actually giving you some default values taken from your Helm chart values to work with the installation of these operators. You can work with these values here, use different values for port or different values for, I don't know, version of the Docker image, just by changing this part and not changing everything. So from maintenance point of view, it's much, much more easier. Going here and ticket store operator and say kubectl, because we're working with operators, we don't need any other CLI. And say kubectl apply -f config samples charts and install the ticket store as well. And this one's just simply going to connect to the APIs that I previously deployed and get the information from there. And you can see that once I applied it, I'm just waiting for that to be taken into account and instantiated in my app and working there. Go in the topology part, and yes, the ticket store is appearing. So now that we have it and it's up and running, I know it says that is Helm, but in the end, this is managed by an operator. So you can see here that I'm getting my order tickets application, and I can filter things on it and get the categories of the things that I'm adding and just interact with my API and do some some of the stuff that I wanted. So it's pretty much all deployed and all working in an automated way. And now the nice part of using operators is when you're using Helm charts, if by mistake you're deleting a deployment, that's not going to be instantiated again. But when you're working with operators, if somebody in the team does this, deletes a deployment, you see it's going 0, 1, it's going to disappear now for a minute or so. So when this is going to happen, come on, disappear, go away, and be created again. So this is going to go away, but you see it's coming back. The reason being is the operator is looking over all the resources it manages, the well, the Helm charts we're managing, and it creates it again. So it self-heals in case that somebody does these kind of stuff. So it makes sure that you still have an application even if the unforeseen stuff are happening. So this is the power of operators. You don't need to be worried in case somebody's doing this. It's going to be taken care for you. So there are some takeaways, of course, from the session before handling the questions. Just some, side-by-side comparison between the things. So you have with Helm a custom packaging format. Now, something I didn't tell you about Helm is when it comes to working with it, the issues that you can raise or you can complain, let's say, they're typically related to the standard Kubernetes resources. If you're creating your own resources, your own custom resources, then that thing is not 100% bulletproof that it will work in all the scenarios. So this is why operators, even if they're working with custom resource definitions, are a safer way to evolve your automation part in Kubernetes than just using custom resources with Helm. They were great so Helm works great for stateless apps. You've seen that. While on the other hand, operators work great when it comes to maintaining stateful applications, such as databases. And Helm, for me at least, there's a great way for me to check that things are working as expected in a deployment. And I can see everything holistically from release point of view, so I can see the releases that happen to an app, and I can also roll out or roll back to a certain release that was before with Helm. But with operators, I can deploy an application that is configured in a particular way across a cluster, and I can achieve high availability in a much more consistent way. Now, the great thing about Helm is that it has annotations that can trigger automatic deployments, but operators are useful for many operations that are not necessarily that nice. So I remember that for me, 3 years ago, it was a great helper to see that somebody thought of creating operators for making cluster backups and backups for etcd and all these sorts of stuff, which manually, if you try it, is not necessarily a nice thing. Not that I would have loved to do them manually, but if you're learning Kubernetes the hard way or from the documentation, you see that you get a lot of information on how to do that manually, not necessarily via operators. While using operators is a safer way to do backups and to restore things, and it's much more nicer when you have also an UI, because what I didn't share with you is that, for example, let me make this like this. In tools like OpenShift, you have in administrator view, a nice view of operator hub, where you get all the operators and you're just going like this and say Postgres, and you get all the available options and you choose what you want to install. Of course, they come with a license and everything, depending on the vendor. But you get a lot of options of trying out things, and it looks much more nicer to evolve things. So pretty much nowadays, when I need to install Knative, when I need to install Istio, I'm just using this nice interface instead of using the command line when interacting with OpenShift, for example. And it's a greater way to work with things than doing all manually, going into the command line, the dark place, and write the commands. So those were about it. This is where you can find the code. It's on my GitHub, and try it out and navigate through it and see how it works. So all the 3 microservices are there. You can play with them. And sorry for my UI skills. I don't have better UI skills than what I showed you for the ticket store. And now also there are some additional resources that I want to share with you. So there are 2 good books that I personally read. So if you want to learn more about Kubernetes operators, there's one book written by our colleagues, Jason Dobby and Joshua Wood. And of course, if you want to learn more about Kubernetes and its resources and the patterns that are behind Kubernetes, and also this book is referencing Helm at some point in operators, read Kubernetes patterns. I mean, Kubernetes patterns is making a great comparison between Java as a programming language and the patterns that are in Kubernetes and why were they created. So it gives you an explanation on why stateful sets were created, for example, why you need volumes, and all these kind of differences that you should be aware of when choosing certain resources and interacting with Kubernetes. So that was it from my side. Thank you very much for listening to me. And now I am welcoming the questions. And I'm going to share the slides. Don't worry, I'm going to tweet about them after the session. And if I should show again the slide with the QR code, let me know. So thank you.
Thank you, Anna. Any questions?
Don't be shy. You can also ask me afterwards. Okay.
Yes. Who you want to start?
I'm always curious about anti-patterns. Are there anything that we should be aware of?
Anti-patterns. Yes. Well, something that I've seen, that there was a mirage in the beginning that a lot of people are maintaining everything with Helm, because Helm as a concept of package manager was before the operators. So you can start with Helm, for example. Even for databases that nowadays you're installing via operators, a lot of providers create first the Helm charts, and then they are creating the operator based on those Helm charts. It's the best way to evolve when it comes to a stateful app. Just don't use on the long term for management, only the Helm charts. So that's one thing. So in a nutshell, I would say that Helm charts don't work in terms of maintaining stateful apps, upgrading stateful sets. That won't be a nice way to do it. You would need something else to back up and restore your volumes that are associated to those stateful sets besides just the regular Helm commands. What else? Anti-patterns. Make sure that for what you're planning to do, operators. I know that there are a lot of APIs and helpers nowadays, especially in Java. You can create your own operator in Java, but be wise when you're creating an operator and make sure that, my screen got away, and make sure that you really need that automation. So take a balanced decision at the team level that if you really want to automate that. The reason why I created the ticket store as an operator and maintaining it as an operator is just for you to see that it can be done with the operator SDK, and you can maintain it even across 3 versions with an operator. But on the long term, I think I would maintain the ticket store only with Helm charts and be really okay, because it's a stateless app in the end, and it just connects to other services and consumes data from it. So it's just for demo point of view and demo purpose. And of course, when working with Helm charts, try to use Helm charts that actually have some support from the community, not just some random Helm charts, and install them and go with them in production. So use validated Helm charts. And the same for operators. Try to use operators that somebody has vetted that they're working and they're just not available somewhere, and install them and realize that nobody's there to help you when you have, I don't know, a certain problem with them or a certain aspect is not going as expected there. Hope that answered your question. Yes, there was another question.
Yeah. We have a lot of microservices, and my question is, should we have one operator per microservice or one for all of them?
That's a great question. Sorry? Or maybe no. So it depends on how you want to automate. So the idea behind operators was that I wanted to automate the ticket store. So in this case, it was okay to have it. If you feel that an operator would help you to maintain 2 microservices that are somehow in independence, it would not be a great thing, because it will be against the concept of being isolated and managed independently. I would say that would work. But on the long term, I would say just try to use operators only when you need to automate a lot of stuff, meaning you have resources that your microservice is depending on, and those resources cannot be managed with Helm, like config maps or something that, or resources like volumes or something that's additional that you see that it would require some extra work from you or your team to maintain, and that Helm doesn't do enough for you. So as I said, this was just for demo purposes, not something that you should try at home. Because on the other hand, there are a lot of operators already done by a lot of companies that you can already use and install. So even for Postgres, you saw there's so many options. So first, try to see if somebody did it before you. That would be like a good thing.
And can I add to your answer?
Yes.
So another good example of using, for instance, Helm charts could be the following. Imagine you have kind of a bounded context that is built of a few microservices that should be deployed together and, as you mentioned,
Yeah.
share the same configuration. And then what you want to do, you want to do ABC multiple testing. So you have to deploy several versions of all of your microservices, each on its own namespace. And with a Helm chart, you can basically do this with a single command, basically providing the additional configuration parameters and the name of the namespace. And then the only thing you need to do is you just separate the traffic so it goes different directions. That's probably a fantastic opportunity to use Helm charts.
Yeah.
In addition, lots of open source software can be like easily installed with a Helm chart. I think that's most of the well-known packages have the Helm charts.
Yeah, that's a Helm chart for everything. I think, and this, as you said, a lot of providers opened their Helm charts for the community. And even if you're looking in the documentation on how to start with a certain product, you see that they're giving you the option. You can install this as a Helm chart and try it on, or you can install as an operator. Nowadays, many of them are advising for the operators because it's a managed way, and they want to avoid actually for you to be stuck when you need to evolve. That's that type of service. But yeah, so thanks for adding that. Any more questions? Well, in this case.
Yeah, thank you, Anna, so much.
Thank you. Thank you for having me.